sachet bread into my microphone. Okay, so kiddos, you're supposed to be finding the nth term for the power series f of x equals e to the x. Then find the radius and interval of convergence for the representative power series. Okay, yesterday you guys were starting, well, not even really starting. We were looking at an example. Kiddos, thank you. This was the example we had just started on, true? Okay, let's go ahead and try to finish this example to try to figure out where that whole endeavor card that you guys just wrote down came from, and then we'll try to use it on the new example. So this is where we ended, and we were like, okay, use the ratio test to consider its convergence. Ratio test. What is the ratio test?
N plus 1.
Okay, a sub n plus 1, right? The limit as n goes to infinity of a sub n plus 1 all over a sub n, right? Okay, so hold on. According to what we have here, we're taking the nth term formula. A sub n plus 1, what am I going to have? N plus 2 times x to the all over. And then remember, dividing by, we can just say multiplying by. So I'm going to have 10 to the n all over n plus 1 times x to the n. Okay. Then when I go ahead and keep solving, my 10 to the n will cancel with the 10 to the n part, right? There's only one 10 left. My x to the n will reduce, I should say, with the n part. I have x left over. So then I end up with the limit as n goes to infinity. I know some of you see the answer. I'm just going for it. N plus 2 times x all over 10 n plus 1. True? Now, what is my limit?
1.
No.
1.
No.
No.
No. No.
No?
Nope.
No, because n is just a number.
Closer. I think Jason already said it. Yes.
Woo! Corey got it right.
Okay. Because n is the variable that's going to infinity, x is just staying. Now hold on. Wait. Doesn't the ratio test have a condition for convergence based on the answer to the limit? Less than 1. Just less than 1?
0 to 1.
Because isn't the test, what if, okay, well hold on, let's review the test really quickly. The ratio in the root test, 1 is the separator, right? So greater than 1, what do we got?
Divergence.
Less than 1?
Convergence.
Equal to 1?
No.
Okay. And then for the ratio test, correct me if I'm wrong, is it absolute value?
No.
Is it only for positive terms?
Yes.
Oh, okay. Only for positive terms, meaning, can this go below 0? If it's only positive terms, no, it can't go below 0. So it's going to be, okay, wait a minute. So I can set x over 10 less than 1 greater than or equal to
0.
Oh. Because it won't go negative because it's only for positive terms, right? Okay. So then I could say x is going to be in between.
0 and 10.
Not or equal to though, right?
Nope.
So for the power series that we just had, within the interval of convergence, which we just found, find the sum of the series as a function of x. What are they asking for? Doesn't say partial sum, it says the sum. It does converge between 0 to 10. This is a Taylor series of something. Centered at 0, true? How can we figure out what it's a Taylor series of? Well, the x over 10 could be geometric, but the n plus 1 says it's not geometric. I mean, look at it, right? That's not going to be geometric. This is one where we're trying to match it to a function. Not sine because it doesn't alternate.
e to the x over 1 over 10 to the n. 1 over 10 to the n times e to the x.
1 over 10 to the n times e to the x. What's Corey seeing that he's saying e to the x? He's seeing x1, 1 plus x squared plus x cubed. True, but now we have all those coefficients, right?
Well, it's 10 to the n on the bottom.
So 1 times n e to the x.
So if we were thinking e to the x,
times n over 10 to the n, right?
but we want it as a function of x. We don't want n's in there at all.
Have factorial for e to the x. So it should be 2 x squared over 2 factorial.
I just forget to write it. I don't know why. Achilles heel. Is that working well?
Is there any way we're still like a power like a geometric system?
No, we can't
Is there
because
any
there's no
way we can get rid of
combination.
factorials like we did yesterday?
How we get rid of factorials yesterday?
Like the top match the bottom every single time. No coefficient.
So both split, we get n over.
But we're not supposed to have an n.
Maybe take a derivative.
Can it be 1 over 1 plus x? Because that doesn't have anything.
1 over 1 plus x?
1 minus x.
Oh, 1 minus x.
Yeah. Times n.
Because that would be my 1 plus x squared plus x cubed.
And there's nothing on the top.
There's no factorials to worry about.
And then if you take it times n for values greater than 1, then you get the coefficients.
I mean, technically, it could multiply the top by 1 over 10. Yes,
Why did it make x over 10?
so
n plus 1.
yeah,
On the bottom gets.
so when you plug
You're
in,
right, you're right.
you get x over 10 x squared.
And then the numerator has to be n plus 1.
But I don't want n's.
You know, 1.
It's supposed to be in terms of x.
Coefficient of the derivative of the next term. That's, I mean, I don't know how you'd say that, but it's the coefficient of the derivative of the next term. Like x.
That's what it is, because when you derive it, you can get 1/10 plus 2
Well,
over.
the coefficient of the numerator of the derivative of the next term.
No, can you take the derivative?
No.
You guys are seeing why they're thinking derivative, right? Bring down the 2, bring down the 3, bring down the 4. But the problem is if I bring down the 2 right now, do I want 2x over 100?
No.
Hmm.
2x over 10.
Why is that good?
Then
Then
it
you
would
can take the
simplify.
derivative.
Because then you take the derivative. I really hope a 2 gets brought in.
Because then that'd be x over 10 times 10, right? And x squared over 100 times 10, and x cubed over 1,000 times 10. Aha! Derivative of that will be 0, derivative of that will be 1, derivative of that will be 2 tenths x,
2x over
or 2x over 10, 3x squared over 100. Ooh, so wait, I'm not quite done, but all I need to do is take the derivative, right? And the derivative would be?
Bottom, the top, on the top.
Wait a minute, why don't we just simplify this little, right? Can I just multiply top and bottom by 10? So I can say 100 all over 10 minus x. That's what I'm taking the derivative of, so d dx, which would end up equaling -1, but times a -1. So that'd just be 100. Woo! Was that easy? No. Does it work? but only on the interval 0 to 10, which means if you go left of 0 or right of 10, it's going to diverge. Does that make sense? But on the interval, this infinite, thank you, sir, he's on a mission. This function, this infinite power series, is going to be converging to that function. Now, let's get back to an endeavor card, huh? Something that we can stake on, something that we can build off of. Does it make sense that they have written for the interval of convergence, which sadly I guess is the slide before that I want to see our ratio test work. So I'm going to put these out of order just for a second so we can kind of see what's going on. Zoop, zoop. There we go. Okay. Does it make sense then for an interval of convergence that if it's kind of built off the idea of the ratio test, are you guys sure the ratio test is an absolute value?
No, it's just for positive.
But it says positive. Oh, so we didn't need absolute value. Okay. Because it's for positive terms. That we're using the a sub n plus 1 of x to the n plus 1, so the n plus first term of the entire power series, all over the nth term, and the limit as n goes to infinity, since we can have positive or negative to converge, needs to be less than 1, which means greater than negative 1, less than 1. So therefore, what is the one thing that we have to come back to this problem and change? If we were doing convergence and divergence, what would need to be true of this series?
N plus 1. X to the n plus 1.
X would need to be established, and we would need to be able to see that it's only positive, right? But if it's a power series, are we trying to put any restrictions on X? No. So therefore, what we need to do is going out of the convergence and divergence, which wouldn't have an X present, coming back into the power series, we would need to change this from a negative 1 to a positive 1, because we are not guaranteed what X is. We're trying to figure that out. And X can be anything positive or negative. So that's where it kind of goes away from the ratio test, because the ratio test is only positive terms. Therefore, we're going to change our interval of convergence not to be between 0 and 10, but to be between, yeah, negative 10 to 10. Because in the interval of convergence, we're dealing with absolute value being less than 1, aka greater than negative 1 without the absolute values less than 1. And the reason being why we have to move away from the ratio test just a little bit is that says only positive terms, but now we have an unknown X that can be positive or negative. So we have to expand our reach just a little bit from the test itself as we were used to it. Zoop, zoop, zoop. And long story short, guys, this is just how we find the interval of convergence, showing you how it kind of applies to the ratio test. It is not the ratio test, so it's okay that's a little bit different. And once again, it's for power series where x's can be positive or negative. Here's the dilemma. Here's what's new, here's what's different. For the ratio test, what happened if the limit equaled 1 again? You don't know anything. Does it make sense that we're going to say for sure the power series will converge less than 1, but at 1, we have to check? Guess what one of the most common things to forget on interval of convergences are? Which means what I said just a second ago in between negative 10 to 10 is completely and utterly true, but what do we not know? What's going on at negative 10 or at 10? So if I was to go back to the example that we just had, this would be true, but it might not be fully true. We would have to say, okay, that is, or in between, this power series does totally converge, but what about when x is negative 10, and what about when x is positive 10? We're going to have to go back to the very beginning and say, all right, well, hold on, what if x was negative 10? Okay, then we're wondering whether this series converges. Hey, 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 chapter 9 OT. Convergence divergence test, parting C. If you plugged in negative 10 to the n, all over 10 to the n, or if we plugged in positive 10 to the n. Why does it diverge on either way? The nth term test, right? So for these ones, the limit as n goes to infinity of either, there you go, is 1 or technically negative 1 or 1, right? neither of which equals 0. So what is my final interval of convergence? Right there. Look at your Endeavor card. Isn't there something extra besides testing the endpoints? What's at the very bottom? What would be the radius of convergence of this one? Not 5.
The distance of the limit.
10.
10. Oh, the distance is 20.
Does that make sense? So from the center, it will converge 10 to the left and 10 to the right, aka half the distance in between. That's the Endeavor card. Kiddos, what number are we on? 20 what? 9. Thank you, thank you. Endeavor number 29. So let's see if we can use it on the new example you guys have written in your notes. It is not the ratio test, but in a sense it builds off of the ratio test. And so maybe that will help you in remembering what you're supposed to do. The n plus first over the n. The absolute value needs to be less than 1 or in between -1 to 1. Testing the endpoints, because at 1 we know nothing. Okay, this one says, find the nth term. What? Because we can't figure out the interval of convergence if we don't have the nth term, so we have to start there. So the nth term, hold on, e to the x, who's he equal? We just talked about him. 1 plus x plus, keep me honest, thanks Jason, plus x cubed over, what's the nth term? Is that good? So if I'm trying to find the interval of convergence, think ratio test. The absolute value, except with absolute value. The absolute value of you guys get ahead of me. What am I missing?
The others, what it's greater than? The other side, -1. -1? 0, 3, 4.
What am I missing? Yeah.
Limit.
Didn't I teach you guys to always write the limit?
Yes.
Struggle. See, I teach it to you because I forget it too sometimes.
Woo!
What is the limit? Whew, not just, wow, that was a jump. 0, less than 1. Answer? True. Wait, what? Where'd my x go? How am I supposed to figure out what x can be? No, x is not a constant. Always true. Regardless of whatever x may be, the limit will always be 0, which will always be less than 1. So, interesting, this infinite power series converges to e to the x for all x values. Why is the radius infinity? We can think what's half of double infinity, but it doesn't even work like that. Cut an ever-increasing number in half, and you still have an ever-increasing number. The radius is indeed infinite. We can think of, oh, from the center, infinitely that way, infinitely that way. Yeah, it's infinity, however you think about it. That's pretty cool. That one converges no matter where. Does that make sense, guys? If you didn't have the limit, wouldn't you have had n's? We don't want n's. We have to take the limit, and then we can go ahead and then think about the less than 1. Is that okay?
Wait, Miss B?
Yeah.
What is zero? Is that zero or zero?
Zero over zero.
Wait. If x is 0, 1, if x is 0, 1. You're thinking about the
general.
a sub n plus 1 over, but I'm 0. Oh, 0 factorial is defined to be 1.
Yeah, but then you have 0 to the 0. Because if you're starting at n equals
Oh, you're saying when x equals 0.
Yeah.
Well, you're looking at the nth term and not realizing the nth term is describing. I see what you're saying. But 0 to the 0 is indeterminate. I don't think it's truly a loophole, though. Because if you look at the general term is just trying to describe what's going on. If I see the series, e to the 0 is 1 plus 0, like, I don't know why you would plug in 0 to the 0. Because according to our Taylor series, we're trying to do f of 0 for the first term, right? So it's not truly built on that. It's built on f of 0, f prime of 0, f prime of 0 times x to the 1 all over 1 factorial. Like, that's what it's built on. So I think that's more of just an exception where the general term, the indeterminate, wouldn't show me what it is. I'd have to keep going and think of it in another light. Does that kind of make sense? But interesting observation, definitely. Fine, ooh. Okay. Be sure to, wait. Oh my goodness, I even highlighted it, guys. First I forgot writing the limit, then I forgot about testing the endpoints. Okay, wait. How do we test just kidding. Are there endpoints? Okay, just making sure. If I freak out, then maybe you'll remember the endpoints for other problems where it does matter. Okay, what about this guy? What should you write first?
The problem.
Okay. Thank you for the reminder. Let me pause.
I'm sorry.
That's very, very good observation. I'm going to go eat some more brace bread. Katrina, you can just hang out for a little bit and write directions too.
Hi, Katrina.
Ethan, you too.
We're on the floor.
They are on the floor.
Country concert right now? Oh, no, that's not funny. Is that a word? Congratulations.
P.S. You guys should all follow HCS_missions 2018.
Hi, Ethan.
And then you should find my Insta and like my post about Havana Nights. Follow, like my post. Follow, and then I know. I know more than I say. Here you go. I'm snapping Katrina. Oh, that's interesting. She will hear in the future the reason I'm taking the picture in the past. Whoa.
Hi, Ethan. I didn't forget about you.
There you go. Okay. Now can I ask you, what would you do first?
Yeah.
Okay. After writing the problem, what would you do first to solve the problem?
Put in the limit in the
Thank you. Put in the limit.
The absolute value.
Absolute value. M plus first. Wait, absolute value. Do I even need to care about the -1 guy?
No.
Forget him. Okay. X minus 5. Don't forget him. He's very... Anyway, keep going. So n plus 1 all over n plus 1, 2 to the n plus 1. Oh, this will be interesting. N, 2 to the n, all over x minus 5 to the n. Okay. Got a little extreme. I'm going to come over here and make them a little bit smaller. Anyway, as I do that, you guys are simplifying, right? Where's the love? Sometimes love is a choice. Ooh, it's not always a feeling or emotion.
Love who you choose. You choose who you love, and you love who you choose.
That's good marriage advice right there. All right. Marriage advice can also be friend advice, depending on the advice.
Mr.
Will doesn't believe in dating.
You should be friendly. Okay. Shh. I just said the marriage advice can be applied to the friend advice, so be treating friends with some of the same respect, choosing them above you, that maybe could apply to marriage as well. Okay. You guys have simplified stuff, right? Like 2 to the n cancels out with the n part. X minus 5 to the n cancels out with the n part. We end up with the limit as n goes to infinity. of nx minus 5 all over 2n plus 1. You guys agree?
Yep.
Yeah. It would be x
What's the limit?
x minus 5 over 2. Isn't it x over 2?
Right? Because the degrees are tied?
Yeah.
So x over 2 are the coefficients?
Mm-hmm.
Wait, hold on.
Why is that minus?
True, good point. If you distribute the n's, x and 5 have an n, so both of them are the coefficient. Now hold on. I'm going to do x minus 5 all over 2 is less than 1, greater than negative 1. Multiply by 2 and then add 5. Don't miss it because you're just doing mental math a little too quickly. So I end up with x is between 7 and 3. Is that true? Yes. Is it complete? Maybe not. Because what do I not know anything about? At 3 or at 7? So therefore I have to think about at x equals 3 and go back to the very beginning of, well, I have an infinite series. All right, that infinite series at x equals 3 would look like n equals 1 to infinity of, hey, it's alternating, right?
Yep.
That's important because I have to actually test the convergence and divergence right now. Plug in 3. 3 minus 5 is negative 2 to the, uh-oh. Wait, I have a negative and I have another negative? Maybe it's not alternating anymore. All over n times 2 to the n. You guys are considering him as I'm just plugging into the other guy as well. I have negative 1 to the n plus 1. When I plug in 7 minus 5, that's going to be positive 2 to the n. All over n times 2 to the n. You guys are seeing this guy simplifies. What's going on with the top guy?
It just goes back and forth.
Couldn't I change this guy to be negative 1 to the n times 2 to the n? Couldn't I change it to be that? Then couldn't I go ahead and simplify the 2 to the n's? Then I could rewrite this guy to be negative 1 to the n plus, no, to the 2n?
Plus n.
Uh-oh, is that good or bad?
It'll still alternate.
To the 2n plus 1.
No, because that make it odd. Wait, it's an odd.
Ah, so the 2n is dangerous, but the plus 1, doesn't it kind of save us?
Why is that 2n plus n?
Because I have n plus 1 like bases, I add their exponents, n plus 1 plus n. So if I plug in, that is going to be even, but plus 1 will always make it odd. So wait, always make it odd?
Oh, so it's always negative.
So it's always negative,
But it's still negative.
which means it's not alternating.
But doesn't it still negative? It's still 0, though.
Which means, can't I just pull out a negative?
Yeah, it's divergent.
Now pause. If it was alternating, this would converge conditionally, which we would say converge, right? So it's very important that you realize, yes, the negative 1 is still there, but the negative 1 is always there. This does not converge by the alternating series test. This diverges by the p series, p equals 1. Careful. If you thought it was alternating, diverging would be wrong. But I can say, yes, diverges, p series, p is 1. Which means, not that endpoint. Oh, so it must not be the other one because, of course, whatever one does, the other does. False. Check it. What is this one doing?
That one's alternating.
Alternating. Alternating series test says as long as the terms decrease, check, and the limit goes to 0, check. The series, don't care whether it's conditional or absolute, the series converges, which means keep the 7, get rid of the 3. So x is going to be in between open at the 3 and closed at the 7, or greater than the 3 and less than or equal to the 7. Kyle. Yeah. I have negative, well, does it make sense I pulled the negative 1 out of the 2? Yeah. So then when I look here, like bases, you add the exponents, so n plus 1 plus n. Add the exponents when you have like bases. No. If I have x squared and x cubed, it's x to the 2 plus 3. Whenever I have like bases being multiplied, you add the exponents. So negative 1 to the n plus 1 times negative 1 to the n is negative 1 to the n plus 1 plus n.
Okay, so you split negative 2 to the n to be negative 1.
Okay. Next one. Wait. I've taught you better than this. You finish, you have an answer, you go back and you double check that you did everything that they asked you, and then you're like, oh, I didn't. Radius. 1/2 of 7 minus 3. But it's not at 3. I don't care. It's still a boundary. So therefore, remember, at 3 is an infinitesimally thin, a.k.a. dimensionless, a.k.a. no width location. So I don't care that it's missing at 3. The distance between is still 4, and 4 divided by 2 is 2. I give up. Okay, so it's like a limaçon. Zoop. Ready, set, get ahead of me, and then I'll start playing. Ready, set, get ahead of me, then I'll start playing. Yeah. Ooh, yeah. But you're not cutting all of them, right?
No.
Okay.
But, like, how long do you want all of them to be there?
I would say maintain as much length as possible,
Okay.
but if he doesn't have extra wood, then go ahead and cut a couple down.
All right.
Is that cool? Just because it's for, like, it's
So, like,
it's
how
for a
big?
whole event, so the bigger we can make it, the better.
Okay.
Is that cool? I love that stain, though. That's awesome.
Yeah, this is just a sample, though.
Perfect. No, that's great, though, Cameron. Thank you. Go, team. Look at that kid. Katrina, it was a great idea. Cameron's doing an awesome job.
Good job, Kat.
All right, you guys are going, right? So I can catch up? Okay.
New desk.
It's actually me.
I don't know how Katrina was over.
It's either that or his legs. Make a choice.
Question. How did I take the limit? A few of you guys might have gotten stuck there. How did I take the limit? There are no ends. So the limit is like a constant. It's just itself. So I can say x over 3 is in between -1 to 1. Wait, didn't I see x minus 3 from the very beginning? Oh. Why was I shushing the people in the front that were saying it's just ratio test from a geometric series? Or sorry, check the ratio from the geometric series. Because it's a geometric series and you can just do the ratio. Yeah. So wait a minute. Why can I box this and be done? So dangerous. Because I can say geometric series. But if this was an interval of convergence, I did not see it was a geometric series, would that be okay to stop? And the answer would be a definitive no. Now wait, hold on. Should I multiply both sides by 3 and make it actually nice? Okay, fine. But still, even though I'm going to multiply both sides by 3 to make it pretty, since I see it's a geometric series, I can say, hey, the ratio cannot be at 1 and -1. Hence why I can stop. But if I didn't see that, once again, I would need to go ahead and say at x equals -3, at x equals +3. But if you notice, if I plugged in -3 over 3, wouldn't that just be -1 to the n? And what's -1 plus 1 minus 1 plus 1 minus 1 plus 1?
0.
No.
You don't know.
It diverges because it's oscillating. It's not converging to anything. So therefore I'd say diverges by Geometric series, r is equal to -1. Okay, well, not that one. And then this one, r equals +1, because I'd have 1 to the n, which would be 1 plus 1 plus 1 plus 1 plus 1. That diverges too. Wait, am I done?
Yes.
No! Read the directions.
Radius.
Thank you.
Oh.
The radius of convergence is going to be 3.
Give me a 4.
3 minus -3 is 6. The distance is 6. Cut it in half. Shoot. Woo! Wait a minute. Wait a minute. Wait a minute.
Homework's due Monday.
Wow, we're just doing practice problems because really the entire thing for section 10.4 and 10.5. Now wait, hold on. Does that sound like our book? Does it sound like our book that one endeavor card covers 2 sections?
No.
Guess what our book does?
breaks
It goes through all of the convergence and divergence tests while talking about the interval of convergence and the radius of convergence. We did all the parting C as our own little unit. Then we came to chapter 10 and said, okay, we know how to do these 2 sections. As long as you teach us interval of convergence and radius of convergence. Okay.
Is homework still due?
I say no. Homework is due on. Wait, we're not even done with class. You guys talking about homework? Ready, set, go. Go. Ready, set, go.
But the top power is 2n plus 2. No, it's 2n plus 3.
-1 doesn't matter, right, guys?
He's gonna use the parentheses, then he does
2n plus 1, 2n plus 2, so 2n plus 3. Good. 2n plus 2 plus 1 is 2n plus 3. Times. Come on. The concept is the exact same, just some of you have gotten too used to the shortcut. You can do this. It is possible. You don't need L'Hopital's. You don't need anything else. It's possible to simplify. Because it's n plus 1 and n plus 1. The 2 has to distribute. The 2 has to distribute. N plus 1 goes in. 2n plus 2 plus 1. 2n plus 2 plus 1.
My head is exploding. But not just because
Stick it in the backpack so it doesn't get all over the classroom. Wait, what? Wait, what? Is there a backpack in the classroom?
There is one? We should sue.
it's next to it's next to your recycling thing.
Can we throw it outside the classroom?
No.
Hold on, I'm showing people what to do. Does it make sense that there are 2 x's? It's x squared that's remaining because I need 1 plus 2 to be 3. That will reduce. And then I have n plus 2n plus 1 and 2n plus 2 and 2n plus 3.
What if it's 2 and
Ooh.
Oh, wait, never mind.
Yes, 0 is always less than 1. Negative infinity to infinity. Radius is infinite. Bye, guys.
Homework's still due Tuesday.
Monday. I changed it on the board. Homework due Monday. Bye, guys.
Are you checking for bombs?
Bye, Mr.
Someone dropped it. I just forget who it was.